Hello everyone. Today we'll present for you the topic related to correlation between body fat percentage, body mass index, specific fillet test, and throwing ball velocity in professional team handball player. This is a collaborative project between Qatar University and some colleagues from Germany. To start about the background of our research, the key characteristic of successful professional handball player included many physical capacity like endurance capacity, sprint performance, jumping ability, and throwing ball velocity. In addition, throwing ball velocity is a fundamental skills determined by the capacity of body composition, power, and strength, and also the combination between other parameters like the technique, the timing movement, and consecutive body segment. However, team handball players have recently been described in terms of body mass, body fat percentage, and BMI. Given that the body mass might vary by age, playing position, experience, and competition level in team handball, it becomes important also to consider the parameter of body fat percentage rather than BMI when to investigate the relationship between variable and the physical. The rationale of this study arose from the positive knowledge concerning the determinant of performance level fitness differences in professional team handball players. However, there is a need to clarify the correlation between body fat percentage and the specific fitness test related to team handball. The first aim of this study is to compare the anthropometric and physical performance stratification-based BMI of professional team handball players, and the second aim is to explore the correlation between BMI, body fat, and with the physical fitness and ball velocity. Our first hypothesis deal with that anthropometry and physical performance differ between or between normal and overweight player. The second hypothesis that the percentage of body fat will be negatively associated with the test performance and the reimbursement team handball player. To do this, the method and material, we have recruited 25 players and divided them based BMI aged adjusted group characteristics. The first group included 11 or normal weight group included or composed to 11 players, and the second group, the overweight group, included 14, 11. To proceed with the test sequence, we have started with anthropometry evaluation, then the sprint test, jump test, aerobic capacity, medicine ball through, agility T-half test, and we completed the testing evaluation by the throwing ball. In the table 1, we can check the participant physical characteristic by BMI category and comparison of parameters between both groups based on the first testing step. And here the data are presented as mean and standard deviation. We can observe here there is a difference between overweight and normal weight player in terms of CMG, and also for the bicipital skin fold and BMI. The table 2 is a summary of the linear regression analysis for the anthropometric variable predicting the pre-performance parameter. However, body height and body mass were entered as predictor in step 1, while the percentage of body fat was added in the step 2. We have here to find a correlation between medicine ball through and body fat, and also between agility, jump shoot, and running shoot. In addition, we can observe in the figure 1 a negative correlation between body fat and agility test. The similar observation we can get for the figure 2. However, the U intermittent recovery test explained on distance is correlated also negatively with the body. The largest additional explained variance were calculated for the agility T-half test, sprint, jumping shoot, and regarding the CMG and squat jump, no relevant influence of any predictor was observed. With the exception of sprint performance, a decrease in the body fat lead to higher performance. For example, a reduction of 1% of body fat induced a decrease in time in agility T-half test and an extension of distance covered by the UU of the UU intermittent recovery test level 1 and increased the medicine bore through by 23 centimeters. Uh, Discussion and conclusion. We can say that anthropometry was a difference between the BMI group for the accept of body fat. In this context, the large anthropometric dimensions are ostensibly advantageous in handball. However, jumping, sprinting, and aerobic capacity were not different between the BMI group, but we did observe BMI-related differences in the medicine ball through. Levindi confirmed previous observations about the negative effect of high body fat percentage on both aerobic and anaerobic fitness. In addition, body fat height and body mass alone, the step one were only deterministic for throwing parameters, especially for the running, shoot, and aerobic capacity. Together with body fat, step 2, we calculated the largest for the running shoot, jump shoot, medicine ball through, and agility T-half test. The agility T-half test was also the test with the largest increase. This result is an accordance with the study indicating that greater body fat is associated with lower aerobic fitness in children and adolescent handball play. Overweight participants had lower aerobic fitness in most of the tests assessed, and the differences in playing experience might have influenced the body composition because some positions tend to have a higher body fat than the other player when we compare, for example, the pivot, the back, and the wing. Based on the result presented here, the combination of body height and body mass is a sufficient predictor for medicine bore through UU intermittent recovery test in terms of distance covered, jump shoot, and running shoot. As we mentioned before, lower body fat result in greater performance in almost all parameters except for sprinting and agility parameters. For example, reduction 1% body fat induced an increase in jumping shoot velocity, extension of distance of UU intermittent recovery test, and improve the medicine bore through by 23 centimeters. As conclusion, we can say that professional team handball player from Qatar presented a percentage of body fat equal to 19%, which is high for athletic population. Players with great body fat showed inferior physical fitness. However, BMI was unable to differentiate between the fat and lean mass and player categorized by a percentage of body fat, and therefore is poor indicator or predictor. As practical application, we can say that the result might be useful for coaches and trainers to develop position-specific training concepts as they are based on the test that reflect specific characteristics of individual playing category. Thank you for your attention.